Hello everyone. Today we have a new example related to motion in two dimension, and one of the best application to describe motion in two dimension is a projectile. So I have an object, a ball, launched horizontally at an initial speed of 20 meter per second from the top of 50-meter cliff, and we are trying to find how far did it travel. So with this supported figure, I know how much is my initial velocity. So if I want to draw, that will be my initial velocity on the x direction, the horizontal motion, and it is 20 meter per second. Now, when I'm looking for how far, that's mean how far from the base, or it's the range. So either it's the range or the horizontal distance from the base. That's what we're trying to find out. So uh, let's find that I have the initial x direction velocity, which is 20 meter per second. And to calculate the range or the horizontal distance, I need the initial horizontal velocity multiplied by the total time in air. Now, when I look at what I have from this equation, I don't know how much is the time uh, needed for this object to hit the ground. But I do have other information, such as the height of the cliff. And from the kinematics equations, we can pick the change on the height equal the initial velocity, but it will be the initial velocity on the y direction, because we know from the projectile concept that the x component and the y component, they are independent. And when I'm thinking about how long did it take for this object to hit the ground, I can calculate the time required to this object fall vertically or as a free fall and hit the ground, because it will be the same time required to hit the ground here or here. So the time to hit this object, the ground here, it will be exactly the same time to hit this point as well. So let's find how much is the time. So using the kinematics equation, and it will be half gravity acceleration t squared. Now the initial velocity of the y component, it will be 0. Okay. Now the change in height, it will be negative 50, and that equal minus 4.9, because it's half the gravity acceleration, and it's a t square. Now the negative and the negative will cancel each other, and just following the math, so I have 50 square root. That will give me sorry, I'll try it one more time. It's oops, sorry, 4.9, and under square root, that will give me about 3.2 seconds. That's the time in air. Now I can use this in the range equation to find how far this object traveled horizontally from the base. So the initial speed is 20, that's on the horizontal direction, and times 3.2, that will give me 60, about 64 meter. So this object managed to travel horizontally from the base 64 meter. Okay, I hope you find this video useful, and see you with another one. Thank you.